All right, so imagine this for a second. You're running a massive industrial facility. You've got this one, super critical server handling everything, and you want that thing locked away. Secure, cool, safe. But, and here's the catch, you've got 8 different people, maybe 3 football fields away, who all need to control it in real time.
And that right there is the classic IT paradox, isn't it? Security wants distance, but usability, it demands proximity.
Exactly. So for this deep dive, we're unpacking a piece of hardware that tries to solve that. It's the NTI VOPEX-C5USBVUA-4.
Which is quite a mouthful.
It's a bit of an alphabet soup name, yeah. But its mission is really specific, solving that long-distance relationship between a computer and, well, its user.
Right. At its heart, this is a VGA USB KVM splitter and extender. But just saying that, it really undersells the engineering here.
Yeah.
We're not talking about a 10-foot cable from your desk.
Yeah.
We're talking about keeping a perfect signal over 1,000 feet.
That's the headline number that really jumped out at me. 1,000 feet. I mean, usually if you run a VGA cable, even a fraction of that length, you get what? Ghosting, fuzzy tech?
Or just snow, yeah. Total signal loss.
So how are they getting around the basic physics of signal degradation here?
So they're using standard CT5 or 5E or 6 cabling, basically the same Ethernet cable you probably have in your walls right now.
Okay.
But the magic, the real trick, is in the signal processing. The unit itself has what they call automatic video quality adjustment.
And what does that mean in, practical terms?
Well, see, different lengths of cable introduce different amounts of skew. It's where the different color signals, red, green, blue, arrive at slightly different times.
Ah, so that's what causes that fuzzy, separated look.
Precisely. This box automatically detects the cable's length, and then it electronically compensates for that delay. And it has to be perfect, because it's trying to push a resolution of 2048 by 1536.
Which is incredibly high for an analog signal over that kind of distance. So it's cleaning up the mess the wire creates before it even gets to the monitor.
Exactly. For up to 8 remote users, all at once.
Now, this is where it gets really interesting for, workflow. This isn't just broadcasting a video feed. It's a KVM.
Right. Keyboard, video, and mouse.
It allows for simultaneous control.
Yes. And the documentation even says that multiple users can enter data into the same program at the same time.
That sounds chaotic.
It can be. But think about a factory floor. Or maybe a command center. You might have a supervisor at one station, an operator at another, and they both need to interact with the same interface instantly. No switching seats.
And it's not just keyboards and mice, is it? I saw the term transparent USB connection. That sounds a little like marketing jargon.
It does, but it's actually a really crucial technical point. Transparent just means the extender doesn't try to interpret what the USB device is. It just passes the data straight through.
So if I plug in, say, a scanner,
A touch screen monitor, a CAT card reader for security, a printer, anything. The main computer sees it as if it were plugged directly into its own back panel. The computer has no idea that device is 1,000 feet away.
it just works. No special drivers needed for the extender itself.
Exactly.
I do want to touch on the audio specs, because usually with industrial gear like this, audio is a total afterthought. You get a beep, and that's it.
Not here. They've spec'd this with a 20 Hz to 20 kHz frequency response. The signal-to-noise ratio is 76 dBA. That is getting very close to CD quality.
Why go to that trouble?
Think multimedia. If this is in a control room, you might need to hear high-fidelity alert tones or maybe voice communications without all the hiss and static you'd normally get.
Okay, we have to talk about the monitor night more. If you have 8 users, you have 8 different monitors, all different ages, different brands.
Different native resolutions. It's the bane of every AV tech's existence.
So how does this box not just, panic when the computer asks what's connected?
This is where DDC emulation comes in.
DDC. Break that down for us.
It stands for Display Data Channel. It's basically the handshake protocol between a monitor and a PC. The NTI unit here, it acts like a diplomat.
The diplomat. I like that.
It talks to all 8 monitors, figures out a table of resolutions that they can all handle, and then it presents that one unified table to the computer. It prevents that situation where one person has a perfect picture and the guy next to them just has a black screen.
It's just smart engineering, all wrapped up in a really rugged package. I mean, the steel case, the built-in surge protection.
Yep.
This isn't for your living room.
Definitely not. This is pure infrastructure.
Which, it brings up one last thought for me. We spend all our time talking about the cloud, VNC, remote desktop software. Why do we still need a physical box like this?
2 words. Latency and security.
Oh.
Software solutions, they all rely on networks. Networks lag. Networks can be hacked. A copper wire doesn't lag, and you can't hack a VGA cable from across the internet.
So sometimes the old way, just physically plugging something in, is still the best way. Well, that's it for this deep dive. Thanks for listening.